In 1977, Caterpillar unveiled a machine that would fundamentally change the bulldozer industry. The D10 wasn't just larger or more powerful than its predecessors. It represented a revolutionary engineering approach that solved problems the industry had wrestled with for decades. This is the story of how Caterpillar built the most powerful track-type tractor of its era and transformed heavy equipment design forever. By the late 1960s, Caterpillar faced a problem. Their flagship D9 bulldozer, powerful as it was, had competition breathing down its neck. The heavy equipment market was changing and rivals were building bigger machines. At ConExpo 1969 in Chicago, Alice Chalmers made a bold statement. They introduced the HD41, a 524-horsepower crawler that claimed the title of world's largest bulldozer. The gauntlet had been thrown down. Caterpillar's D9H, with its 400 horsepower, suddenly looked underpowered. In 1974, after Alice Chalmers and Fiat merged their construction equipment divisions, they introduced the 41B, maintaining that high horsepower advantage. Caterpillar needed an answer to this growing competition, but the company's engineers weren't interested in simply building a bigger conventional bulldozer. They wanted to reimagine the entire concept. The idea of a tractor larger than the D9 had actually been discussed at Caterpillar as far back as 1955, but it took until 1969 for serious development work to begin. The engineering team knew they needed something revolutionary, not evolutionary. In July 1973, Cat held a major corporate meeting where they unveiled something extraordinary, the D10X1, the first pilot model. This wasn't just a showpiece. It was a working prototype that embodied radical new thinking about bulldozer design. The concept at the heart of the D10 wasn't actually new. It reached back to 1914, when Best Tractor Company, a Caterpillar predecessor, built the Model 30 humpback with an elevated drive sprocket. The design was discontinued after just 1 year. Between 1920 and 1922, the Cletrac Model F used a similar concept. Then the idea vanished from the industry for over 50 years. But why did Caterpillar resurrect this forgotten design? Well, mainly because it solved a fundamental problem that had plagued bulldozers since their invention. In conventional bulldozers, the drive sprocket sat at ground level, integrated with the suspension system. This meant the drive axle bore the constant strain of the vehicle's entire weight, combined with the punishment of rough terrain. Final drives failed frequently. Components wore out prematurely. Operators endured punishing vibration and fatigue. The elevated sprocket system separated the suspension from the drivetrain entirely. By mounting the drive sprocket high on the machine and relocating the transmission behind and beneath the operator, Caterpillar's engineers dramatically reduced stress on both systems. The result was increased durability, better weight distribution, improved traction, and a significantly more comfortable ride for operators. Between 1973 and 1977, Caterpillar built multiple test machines. Prototypes appeared in 1975 and 1977. In March 1977, 10 pre-production units, designated P1 through P10, rolled out of the factory. These machines were dispatched to selected contractor job sites and to Caterpillar's Arizona proving ground. Some were deliberately worked to destruction to determine component life expectancies and identify weak points before full production began. The testing was rigorous and essential. This wasn't a machine you could afford to get wrong. The elevated sprocket system required wholesale changes to bulldozer architecture. Caterpillar embraced modular design throughout the D10. The traditional geared final drive was eliminated in favor of a hydraulic planetary system. In conventional designs, engine torque concentrated on a single gear tooth, creating a point of catastrophic failure. The planetary system distributed forces across multiple gear teeth simultaneously, dramatically improving reliability and torque handling capacity. The track frames became completely independent of the final drives, held in place by a massive pivot shaft at the rear and a conventional equalizer bar at the front. This arrangement allowed the track frames to oscillate over terrain without transmitting shock loads to the drivetrain. Another innovation, independent bogies holding the bottom track rollers. Rather than ramping up over obstacles, the tracks wrapped around them. This reduced point loading and improved traction in difficult terrain. The elevated sprocket design did have one disadvantage. The track now traveled around one additional idler, which theoretically reduced track life. Caterpillar addressed this with its sealed and lubricated track system they'd introduced on their track-type tractors in the early 1970s. For serviceability, the modular design meant major components could be removed with unprecedented ease. The power shift transmission or final drives could be extracted in just over an hour, a fraction of the time required on conventional machines. For contractors working on remote job sites, this was revolutionary. To power the beast, CAT selected the D348TA, a V12 engine with twin turbochargers and aftercooling. The engine wasn't new. It had proven itself since 1968 in the 777 off-highway hauler and in the 992 and 992 B-wheel loaders at 550 horsepower. But for the D10, Caterpillar tuned it to deliver 700 horsepower, making the machine the most powerful track-type tractor ever built when it launched. The D348 featured a bore of 5.4 inches and a stroke of 6.5 inches. The twin turbochargers provided the massive airflow needed to produce that power reliably. The aftercooling system kept intake temperatures under control, ensuring consistent performance even in extreme heat or at high altitude. This engine mated to a Caterpillar barrel-type planetary power shift transmission with 3 forward and 3 reverse speeds. The track gauge measured 9 feet 6 inches. Standard track shoes were 28 inches wide, though other widths were available. The D10 could be ordered with several blade configurations. The S was a straight blade. The U was a full U blade measuring up to 19 feet wide and 7 feet high, capable of pushing 35 cubic yards of material according to Caterpillar's specifications. The C was a cushioned blade designed specifically for pushing scrapers. The most common ripper was a fully adjustable single-shank unit with hydraulic pin puller, though a multi-shank model was available. For a time, Caterpillar offered a specialized impact ripper, though this option was eventually discontinued. Operators could choose between an open, rollover protection system or a fully enclosed cab with climate control and sound suppression. The cab was isolation-mounted from the tractor frame to reduce vibration. Inside, the suspension seat angled 30 degrees to the right, giving operators excellent visibility of both the blade and ripper. All control levers featured short throws and were closely grouped to minimize fatigue. Notably, no pedals or levers penetrated the floor plate, reducing heat, dust, and noise intrusion while making cab entry and exit easier. The D10 weighed 180,000 pounds in its initial configuration, though later versions increased to 190,000 pounds. Overall length with blade and ripper was 31 feet. Width with the S blade was 18 feet. Height to the top of the protection system was 14 feet 10 inches. This was a massive machine, but the design maximized every pound. Caterpillar officially unveiled the D10 at a dealer meeting in September 1977. The November 1977 issue of Excavating Contractor magazine ran a 2-page feature titled "Cat Uncorks the New D10", and the industry took notice immediately. First deliveries didn't occur until 1978, but when they did, demand exploded. At its peak, Caterpillar maintained a substantial waiting list for new machines. Between 1978 and 1986, nearly 1,000 D10 units were manufactured at Caterpillar's East Peoria, Illinois plant. To put this in perspective, the D10 alone outsold the Fiat Alice and Komatsu competitive machines combined. Caterpillar had not only matched the competition, they'd leapfrogged them entirely. The D10 could accomplish roughly 50% more production than the D9H. For contractors, this translated directly to faster project completion and lower operating costs per cubic yard moved. Mining contractors particularly valued the D10 because it could rip material that previously required blasting. This eliminated the costs, delays, and safety concerns associated with explosives. The machine excelled in quarrying, large-scale earth-moving, and subdivision work. D10 bulldozers found their way to projects worldwide, and operators universally praised the early D10 model. The elevated sprocket system delivered on its promises: smoother operation, less fatigue, better visibility, and impressive reliability. However, there was one early issue. The initial D10 units featured a single large exhaust stack mounted at the front of the hood. This configuration caused heat buildup in the turbocharger area and created excessive exhaust back pressure. Following a few reported engine problems, Caterpillar redesigned the exhaust system around 1980, replacing the single stack with two separate stacks, one on each side of the hood. This modification became the defining visual characteristic of production D10s. Interestingly, Caterpillar had anticipated potential fire risks during development. Every D10 came from the factory equipped with a fire suppression system in the engine bay. To understand the D10's impact, consider Caterpillar's bulldozer lineup at the time of its introduction. The range started with the 62 horsepower D3 and progressed through the 410 horsepower D9H. The 700 horsepower D10 represented a massive leap to the top of this range. The elevated sprocket system proved so successful that following the D10's introduction, Caterpillar eventually adopted it across their entire track-type tractor range, with the exception of the smallest D3 model. Remarkably, no competitor has matched this design approach. The elevated sprocket configuration remains unique to Caterpillar products. The development of the D10 generated 93 patents for Caterpillar, protecting the innovations that made the machine possible. This intellectual property gave Caterpillar a sustained competitive advantage in the large bulldozer market. One of the first production D10s still sits in front of the East Peoria plant where it was built, an evidence to its historical significance in Caterpillar's product line. In 1986, Caterpillar introduced an even larger machine, the D11N, rated at 770 horsepower. The D11 adopted and refined the elevated sprocket system, carrying forward the D10's revolutionary design principles. With the D11's introduction came a model number reorganization across Caterpillar's large bulldozer lineup. The D11 replaced the D10. The D10N replaced the D9L. The D9N replaced the D8L. A new D8N was introduced, smaller than the previous D8L. This shifting nomenclature has created a lot of confusion in the decades since. To add to the confusion, the most recent D10 models are not direct successors to the original D10. They're essentially downsized versions in the old D9 class. The true successors to the original D10 are the D11N, D11R, and today's D11. Machines that occupy the same weight class and power range as the revolutionary 1977 D10. Production of the original 84W series D10 ceased in 1986 after approximately 1,000 units had been built. Though its production run lasted less than a decade, the D10's impact on bulldozer design continues to this day. The Caterpillar D10 didn't just respond to competitive pressure, it redefined what a bulldozer could be. By resurrecting and perfecting a forgotten design concept, Caterpillar's engineering team created a machine that was more durable, more powerful, more comfortable, and more productive than anything that came before it. The elevated sprocket system solved problems the industry had accepted as inevitable. The modular design transformed field serviceability. The sheer power enabled contractors to accomplish work that wasn't previously possible without explosives. Nearly 50 years after its introduction, the principles pioneered in the D10 remain at the heart of Caterpillar's largest track-type tractors. The D11 family, now in its T iteration, still uses that elevated drive sprocket configuration. No competitor has successfully matched it. In the history of heavy equipment, few machines have been genuinely revolutionary. The Caterpillar D10 earned that distinction. It didn't just lead the revolution, it was the revolution.